All right, welcome back, everyone. Today is Tuesday, August 5. Yesterday was a holiday, so there was no class. And as always, let's take a look at the course outline to see what we need to do today. So I've already highlighted today's the sixth lesson of this summer school, August 5th, and we are working on 2.4, 2.5 probabilities. Today there's a quiz and an assignment due, so make sure you check that off. This is different from assignment 1, the unit 1 task. This is assignment 1 for unit 2. So just take a look at that over here. Unit 2, data management, assignment 1. So it's due tonight at 11:59 p.m. So good luck. And the same rules for assignments, which you should have some experience from the previous assignment, which is, you can either print it out or write on it digitally, not typing, or just get a piece of paper and then write your answers clearly and make sure it's in proper question number sequence, and then scan it as a PDF and upload it. If you're still having issues with that, obviously, talk to me, let me know, email me, come to the office hours, and then we'll figure it out. So let's start the lesson. Today's lesson is lesson 6. So that's this one here. You got a Google slide, or if you're checking these notes out, it will be 2.4 and 2.5. Okay, session 6, probability. We're getting started now. Today's agenda: minds-on activity, learning goals, probability, measuring probability, theoretical probability, experimental probability, today's work, and then we got questions. All right, learning goals. By the end of the session, you should be able to calculate theoretical and experimental probability and solve problems relating to probability. Success criteria: explain the nature of probability and how it relates to everyday life. Explain the difference between theoretical and experimental probability in everyday life. Where do we see it? Good question. Probability in everyday life. In everyday life, we represent probability using descriptors like unlikely, probable, assured, etc. We can represent probability using a probability line. Going from left to right along the line, the terms describe outcomes of increasing likelihood. Basically, probability is just how likely something's going to happen. So, say every morning, so your mom or your dad, so they wake up and at 7 a.m. every morning. So you're at night, you're like thinking, okay, tomorrow morning at 7 a.m. How likely do you think your mom or your dad's going to wake up at 7 a.m.? And you're probably going to be like, you know what, it's very probable, or it's assured, meaning like 100%. And you might be right, because the alarm goes off and they wake up at 7 a.m. Or maybe tomorrow's like a special case and the phone battery died and the alarm didn't go off, and then maybe they woke up a little bit later at 8 or something. So probability, it's not always 100%. That's kind of like something you should know. Some things are 100%. But yeah, it's probability. That's what that is. How likely stuff is going to happen. So here we got practice real probability. A, someone owns a black car. Someone owns a helicopter. Someone owns a car, and someone owns a yellow car. So how probable are these things? Using these words, unattainable meaning like 0 probability, assured meaning 100% probability, and then like highly improbable, it's not going to happen, doubtful, expected, very probable. So someone owns a black car. I mean, that's kind of like expected. There's definitely a lot of people, or maybe very probable even. Someone owns a helicopter. That's highly improbable. I mean, there's definitely at least one person that owns a hospital, so I wouldn't say it's helicopter. So I don't think it's unattainable, but I'm going to say like highly improbable. Like if, a random person you ask on the street owns a helicopter. Someone owns a car, that's like, very probable. It's not 100% because not every single person owns a car, but it's very probable because I think most people do own a car. Someone owns a yellow car, same thing as the black car. It's one of those things where it's expected, or maybe kind of like they definitely own a. I mean, they may own like a yellow car. So maybe, so maybe it's doubtful actually, because yeah, maybe they own a car, but maybe it's not yellow. So probably doubtful. All right, here you have dinner at a restaurant. How probable is that? Maybe expected, maybe doubtful, depending on the person, right? Like you would know yourself. Like some people go to dinner at restaurants like weekly. Some people maybe they go like once in a year. So yeah, you eat chicken for dinner. Same thing. It's like you would know if you talk to your mom or dad, and then what's it called? You see the chicken, or they tell you that we're having chicken for dinner. It's a very probable. Whereas it could be highly improbable, depending on maybe you're having pizza or something. So yeah, you get food poisoning from your dinner. So that's probably doubtful or highly improbable. I don't think you'd get food poisoning, but it's not zero. Some people do get food poisoning. So not very probable, I would say, to getting food poisoning. And then you eating dinner tonight. So once again, you're eating dinner tonight. That's probably very, very probable, almost assured. Because most people, I think, eat dinner daily. Then again, may not be most people. And maybe it's doubtful that you'll have dinner tonight. So it's different for, different people, the probability. All right, measuring probability. How can we do it mathematically? So initially, we were just kind of using words and describing, okay, something's probable, something's not that probable. But what if we want to use math? Well, what is probability in mathematics? Probability is the measure of how likely something is to occur. Probability is typically expressed numerically in one of three forms. You can use percentages between 0 and 100%. 0 meaning, it's impossible for that thing to happen. 100% meaning 100% is going to happen, like absolutely. And obviously 50% is 50-50, and then, the scale is 0 to 100. Fraction, you can also use a number between 0 and 1. Fraction meaning like 1/2 or 1/3 or 1/4. Excuse me. Like 1/10 or 1/100th, whatever fraction between 0 and 1. And then decimal between 0 and 1 as well. So 0.123 or 0.57. You'll notice that these three things can be interchangeable, meaning you can convert a decimal into a fraction and a fraction into a decimal. You can also convert a decimal into a percent and a percent into a decimal, and then also fraction to percent and percent to fraction. For example, 50% as a fraction would be 1/2. And as a decimal, it would be 0.5. So that's just an example. All right, express the following probability in all three forms. This is pretty straightforward. I think you guys can do this. But I'm going to teach you a technique that's foolproof. So like 100% you'll be able to do it. All right, so 3 over 5. You know what you do? Get a calculator. Do 3 divided by 5. What do you get? If you have a phone, use your phone calculator, I guess. 3 divided by 5, excuse me. Yeah, thank you. 0.6. Boom. So there you go. That's how easy it was to convert it into a decimal. You just use a calculator. Now, this is a fraction, this is a decimal. What about a percent? If you're not sure, to go and write a decimal to a percent, all you need to do is times it by 100. So 0.6 times it by 100, what do you get? The answer is, this is pretty easy, 60%. And there we have all three forms. We got 60%, we got a decimal, we got a fraction. Okay. What if you're given a decimal to start with? Let's see if that makes the things harder or not. Well, once again, decimal, to get a percent, just times it by 100. What is that? That's just going to be 25%. Yeah, exactly. You got it. 25%. Pretty straightforward. I think most students get this one. But what if I want to go from a decimal to a fraction? Very easy. Pay attention. You count the number of spaces there are after the decimal place. So 0.25, there's 2 places after the decimal, so that's going to be 100. You add a 0 for each place. So if there are no decimal values, and I don't know if you remember this from grade 9 or grade 8 or 7, whatever, these are called like the tenths place, the hundredths place, and the next one is like the thousandths place. That's how it's kind of like place value. So you know what, you're at the hundredths place, so you kind of have it over 100. Or if you don't remember that, just count the spaces after the decimal and add that many zeros. So that's 100, and that's going to be 25 over 100. That's how simple, that's how easy it is. And sometimes teachers will ask you, maybe if you want to write that as a simpler fraction, maybe you can reduce it. Maybe you can write it in, lower numbers, numbers that aren't as big. So you can divide both sides, top and bottom, by, let's say, 5. I know 5, you can do that. Just use a calculator. Don't make it complicated. So 25 divided by 5 is just 5. 100 divided by 5 is 20. And if you're good at with your times tables, you'll know that I can actually divide, again, both top and bottom by 5. In this case, you'll get 1 over 4. Or if you just want to jump straight to 1 over 4 and you know that you can divide both top and bottom by 25, you could have done that in the initial step as well. Doesn't matter if you take one step or multiple steps to reduce your fraction. As long as you get to the lowest terms, you're good. So there you have 1 over 4 or 25 over 100. Depending on the question, both can be right. If the question doesn't ask you to simplify, this should be a valid answer. Okay. And then example 3, of course, starting from a percent. If you're starting from a percent, pretty straightforward. Just work backwards. Divide it by 100 instead of timesing it by 100. And 90 divided by 100 is 0.90 or 0.9. If you do this in your calculator, you'll probably get 0.9. But it's always nice to keep 2 decimal places. So I would recommend doing that. 0.90 is your decimal, and then to go from here, you can just write 9d over 100, or if it was 0.9, then just 9 over 10. See how, because there's only one decimal place, you only have 1 0 in the denominator here. And these are exactly the same fraction. Don't believe me, just plug it in your calculator, do 90 divided by 100, see what you get as a decimal, and do 9 divided by 10, see what you get as a decimal, and you should get the exact same answer. So they're the exact same fraction, so one's just more reduced. This is the simpler form, right? Reduced. Okay, let's move on. Theoretical probability, what we expect to see. All right, let's see, what do we expect to see? We have, theoretical probability represents the likelihood of an event occurring. So we got the probability of event, theoretical, equals the number of favorable outcomes over the total number of possible outcomes. That's confusing. We'll get into it. So let's figure this out. Greg rolls a standard 6-sided dice. What is the probability that he rolls a 1? So let's take a look at that. We got a dice. We know a dice has 6 sides, right? One, two, three, and then 4, 5, 6. So there's 6 sides and a dice. So what's the total maximum number of outcomes that you can have? If you roll a dice, can you get 100? No, obviously not. If you roll a dice, can you get 9? No. Can you get 7? No. You're just rolling one dice. Can you get negative numbers? No, obviously not. Makes sense. So you can't get anything, more than 6. You can't get anything less than 1. You have to get a number between 1 and 6. Those are the only possible outcomes. 1, 2, 3, 4, 5, 6. Boom. Okay. So the total number of possible outcomes is 6. And the number of favorable outcomes, what does that mean? Well, we know that there's 6 sides on a dice.